Hello everyone, welcome to another Algebra and Trigonometry with Professor V. So for these problems we're going to be talking about scientific notation. These two problems they're giving us decimal and we're going to express them in scientific notation. So it's a pretty easy process. What we really have to do is count decimals. Scientific notation will be with one digit to the left, so let's go ahead and do this. So this is going to be 1 space 2 space 3 space 4 5. So we're going to end up with 3.14, and that'll be times 10. But since we are technically traveling to the left, right? I mean, we did travel to the right for this, but when we re-multiply this, we want this to be by -5, okay? So that's how we would represent 0.0000314 in scientific notation. Now here we have the decimal all the way at the beginning, right? So we're going to be skipping 3, 6, 7, 8. So what we should land on for this one is 1.48 times 10 to the power of 8. And that's just how they write the scientific notation. There's always one digit to the left where you place the decimal. So why that is, I'm not exactly aware, but I do know that that is the format that we follow. And for this one, we want a positive exponent because that positive exponent will take us to the right. So we will be moving the decimal to the right. In this particular case, we want the decimal to travel back to the left, right? We want the number to get smaller, so we use a negative exponent. Now, for these ones, they want us to convert each number in scientific notation to standard notation, so we start with 1.6. Since it's a positive 10, we're going to travel 10 spaces to the right, so 1, 2, 3, 5, 6, 7, 8, 9, 10. And for each one of these little ditches we kind of dug, the grooves, we're going to add a 0. And then I'll rewrite it, so that looks like 1, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And then we could add commas for good measure, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's looking like 16 billion, right? Now for the next one, we have 9.8. But that one's times 10 to the -9, so we're actually going to be traveling 9 spaces to the left. And I believe that's going to be with 8 zeros, right? Because if we include this space, 1, we're going to travel 8 more spaces, so those are going to be our zeros, right? So 1, 2, 3, 4, 5, 6, 7, 8. So we could put a leading 0, and then we just fill in all these ditches here, or grooves with zeros. And we end up with 0. So there's 8 of them, right? 1, 2, 3, 4, 5, 6, 7. Oh, did I mess up? Let's see. 1, 2, 3, 4, 5, 6, 7. Yeah, I don't think I went enough, did I? 1, 2, 3, 4, 6, 7, 8. Yep, that was only 8, so there should have been 9 spaces, so I guess I can't count. Sorry about that. But there should be 8 spaces including the 9, right? So it really is just a counting game if you think about it. So 4, 5, 6, 7, 8. So there's the 8 zeros, and then the 9, and then the 8. So that's pretty much how we convert scientific notation to decimal and vice versa. It's not really a hard process, you know, you just have to be careful and count properly. You guys saw that I made a mistake here. But knowing that I'm moving 9 spaces, right, and I'm counting this 9 means that there will be 8 zeros, right? And for this one, there was 9 zeros because we're counting that space when we jump across the 6. So I hope this video was helpful. Please like and subscribe if it was. Comment down below if anything's confusing, and I will see you in the next video. Thank you.